let's look at quadratic sequences, and in particular the nth term. So the nth term of a quadratic sequence can be written in the form an squared plus bn plus c, where a, b, and c are real numbers. In other words, the nth term can be thought of as the term-to-term rule for a sequence of numbers. So how you go from the first term to the second term to the third term and so on. The example says, find the nth term of the sequence 2, 8, 16, 26, and 38. We start by finding the first difference of the sequence. So that's 8 take away 2, which gives us 6. 16 take away 8, which gives us 8. 26 take away 16, which gives us 10. 38 take away 26, which gives us 12. Now if the first difference was the same, in other words constant, then this would be a linear sequence. But because the first difference is not the same, then we know that this is not a linear sequence. So we now work out the second difference of this sequence. So that's 8 take away 6, which is 2, 10 take away 8, which is 2, and 12 take away 10, which is 2. Now because the second difference is the same, we know that this is a quadratic sequence. And generally for any quadratic sequence, the second difference equals to 2a. And so from this equation, we have that a equals to 1. As a result, for the nth term of this quadratic sequence, we now know that a is equal to 1, and so we can write the nth term generally as n squared plus bn plus c, where a is 1 in front of the n squared, which just gives us n squared. We now take away the sequence that is formed by n squared, so that we are left with a linear sequence. So the first term in n squared is 1, because 1 squared is 1. The second term in n squared is 4, because 2 squared is 4. The third term is 9, because 3 squared is 9. Fourth term is 16, because 4 squared is 16. And the fifth term is 25, because 5 squared is 25. And so taking away these two sequences, we have 2 take away 1, which is 1, 8 take away 4, which is 4, 16 take away 9, which is 7, 26 take away 16, which is 10, 38 take away 25, which is 13. And so the nth term of this sequence now is bn plus c, because n squared take away n squared cancels. We work out the first difference of this linear sequence. We have 4 take away 1, which is 3, 7 take away 4, which is 3, 10 take away 7, which is 3, and 13 take away 10, which is 3. Now for the nth term of a linear sequence, the first difference equals to the coefficient of n. In other words, in this case, because the first difference is 3, then b equals to 3. So we know that the nth term of this linear sequence can be written as 3n plus c. And so we can now take away the sequence, which is 3n, from this original sequence. First term in 3n is 3, because 3 times 1 is 3. The second term in 3n is 6, because 3 times 2 is 6. The third term is 3 times 3, which is 9. Fourth term is 4 times 3, which is 12. Fifth term is 5 times 3, which is 15. And we're taking away these two sequences. This gives us 1 take away 3, which is minus 2. 4 take away 6, which is minus 2. 7 take away 9, which is minus 2. 10 take away 12, which is minus 2. And 13 take away 15, which is minus 2. And looking at the nth term, we have 3n take away 3n, which cancels. And so we're just left with c. And we see that all of these numbers are the same. And so we've worked out all of the coefficients. That's a equals to 1, b equals to 3, and c equals to minus 2. So comparing this with the general form for the nth term of a quadratic sequence, we have an squared plus bn plus c. And so for our sequence, we would have 1 times n squared plus 3 times n plus minus 2. In this case, simplifying to n squared plus 3n minus 2, which is the nth term of the sequence 2, 8, 16, 26, 38. We can check our nth term to see if it's correct by substituting in relevant values for n. So we see that the first term in our sequence is 2, and that's when n is equal to 1. And the second term in our sequence is 8, and that's when n is equal to 2. The third term in our sequence is 16, that's when n is equal to 3, and so on. So we can substitute any of these values of n into our nth term, and we should find that we end up with the relevant number linked to that nth value. So in this case, let's check n equals 2. we know that our second term in our sequence is 8, and so our answer should equal to 8. So using our nth term, we have 2 squared plus 3 times 2 minus 2. And so if we simplify this, 2 squared is 4, 3 times 2 is 6, and then we have minus 2 on the end. 4 plus 6 is 10, 10 take away 2 is 8. And so we see indeed our second term is equal to 8. If we check another value, so let's check the fifth term when n is equal to 5, then we have 5 squared plus 3 times 5 minus 2. And so if we simplify this, 5 squared is 25, 3 times 5 is 15, and then we're taking away 2 on the end. 25 plus 15 is 40, 40 take away 2 is 38. And so we see that our fifth term is indeed 38. And so therefore our nth term for this sequence is correct.